Hello, I'm Manuel Azevedo from Azevedo Devices, and in our first review we will be reviewing the VFD modular clock from Akafugu Corporation in Japan. An earlier version of this clock was previously tested by Brian Stuckey in 2014. We are now testing the most recent update, including the shields that were not available during Brian's review. The VFD modular clock arrived as a kit. Shipping from Japan to Switzerland took less than 2 weeks. All the parts were well packed, each on its own bag. The PCBs have a glossy black solder mask with a golden anic finish. A USB cable was also included. The main PCB is protected in its own bag. You can order the tubes from Akafugu. If you already ordered tubes from elsewhere like eBay, it's also possible to order the clock without tubes. This clock can be ordered in Akafugu's own shop, Tindi or eBay. For custom orders, like ordering several or only specific shields, it's preferable to contact Akafugu via email. It's also possible to order acrylic cases. For this test we didn't order any. Some SMD components are already pre-soldered. You only need to solder the through-hole components. Notice the compact and organized layout of the board. There are 4 M3 holes to mount the feet. Most of the components will be placed on the top side of the board. On the back, you can solder the headers for the GPS module. There are also 6 ICSP pins for direct MCU programming. This clock can support different shields with different kinds of tubes, including a different number of digits. Its versatility does not end here. It's powered by a mini USB connector, it runs an ATmega32 MCU, and it shows, when connected to a computer, as an Arduino Leonardo, allowing for easy development using the Arduino IDE. Assembling the kit is straightforward. The provided instructions are clear, and assembling it was a well-spent afternoon. Brian used before a Diet Coke can as a device to show the size of the clocks he was testing. As we are based in Switzerland, why not use a very well-known Swiss object, a 100 gram, 3.5 ounces Toblerone bar. As you can see, the Akafugu clock is quite small and compact. The IV18 shield that I'm using here is one of the smallest. Notice how the shield height when installed on the clock is about 5 centimeters or 2 inches tall. Let's have a detailed look on how the clock is divided into baseboard, the clock itself and the tube shields. This is the baseboard, the heart of the clock. The clock has an ATmega32. It can be powered and programmed by this mini USB connector. Right next to it, there's a voltage regulator, underneath a buzzer, a DC to DC converter. It steps up the 5 volts to the 40 volts necessary for the tubes. Here we can find an RTC that keeps the time when the clock is off, powered by this battery. Here's the EEPROM, and right next to it is the VFD driver. On the back we have button 1 and button 2, and next to them there's the alarm switch. On the front left corner we can see a red and green LEDs. Right next to them there's a reset button to restart the clock. On both sides of the boards we have the female pin headers where the shields connect to. Turning the board upside down, we find the ICSP programmer pads in case you want to reprogram the ATmega without the Leonardo bootloader. I'm sure these were used for the initial programming and testing after the SMD parts were soldered. They might come in handy if you're not using the Arduino platform and you prefer to use another programming environment. And finally, here we can find the pins to connect the Adafruit GPS module. I've soldered this angled header so I can connect my NWTS device, which emulates a GPS using Wi-Fi and NTP. I'll later show how easy it is to connect and use with the Akafugu clock. It can be powered directly from the clock. It's a really compact unit and packs a lot in a very tiny space. The alarm switch is something you usually don't find on other clocks, and this is a simple and solid way to disable the alarm instead of going through the menus or long pressing a button to disable it. Adding a shield is easy. Just connect the shield into the baseboard and power your clock. This IV6 shield, together with a 4-tube IV17 shield, is one of the smallest. Both make a very compact device. When the clock starts, it briefly identifies the shield being used, in this case an IV6. The clock shows 12 or 24-hour time with dots separating the hours, minutes and seconds. It can cycle between time, date, 4-letter words, temperature and special messages that can be pre-programmed for specific dates like Christmas, Happy New Year and many more. You can customize your own messages too in the source code. The temperature is obtained from the real-time clock. The clock's own heat will make the display temperature higher than the average temperature of the room. The 4-letter word feature shows random words. On the 7-segment shields, it can be challenging to read sometimes, unlike on the IV17 shield that we will see later. Still, the effect is enticing. Both the date and the time can be changed to meet your region's locale. As mentioned regarding the time format, the date format can too be changed to month, day, year or year, month, day formats. The clock is versatile and you can notice that much detail and functions were added to it. As an example, when the alarm is active, a small dot is shown on the rightmost digit. Unfortunately, the 16-segment shields do not support this dot. Still, the current alarm status is shown each time the switch is used. Here we can see how fast the firmware can be flashed from the Arduino IDE. It just takes a few seconds and the clock boots after flashing. I've configured a special message to be shown today. It's maybe a little bit difficult to read, but you can read it better later. The IV22 shield also has 7 segments, so it's not so different from the IV6 shield. Connecting it to the clock is easy. Because the IV22 and the IV6 tubes have in general the same kind of digits, the clock also identifies the shield as an IV6 during boot. The large top view IV22 tubes are bright and make this small device seem much bigger. Finally, the last shield is the 6-tube IV4 IV17 shield. This shield can have either IV4 or IV17 VFD tubes. These tubes are virtually identical, so I'll mention only the IV17. The IV17 is a 16-segment VFD tube. Also has 2 dots that were used to write Cyrillic. Unfortunately, according to Akafugu, the VFD driver did not have enough channels, so these dots were sacrificed. It makes the clock less lively, but the lack of dots is compensated by the richness of the 16 segments. All text messages are now easier to read and the chubby look of the letters makes this a very attractive shield. We can now see the message that I programmed earlier, and there's no ambiguity now. One of the best things I like about these shields is the fact that instead of having isolated holes for each tube wire, there's a bigger hole with grooves. Inserting the tubes is much easier. Soldering and aligning can be accomplished by stretching the wires outward into the grooves. The biggest advantage I see is that replacing tubes is much easier than desoldering individual wires. The IV22 shield uses hardware connectors like the ones usually found in the IN12 Nixie tube clocks. See the text review for more detailed photos. Another strong point about this clock is the menu system. You only need 2 buttons, one button to select the menu and a button to select change. If a menu has a sub-menu, this is shown by a dash at the end. Not pressing any button for 2 seconds closes the menu. Cycling through the menus requires some time to get used to, mostly because of the small timeout, but once mastered is quite easy. As an example, for setting the brightness, press button 1 to cycle through the menus until Brit appears. Then, press button 2 several times until it reaches the desired brightness level. Before we finish our review, I'd like to show GPS synchronization. For that end, I removed the battery from the clock. The real-time clock will not maintain the time when there is no power. As the clock boots, you can see that the time is starting from midnight. The battery only keeps time. Clock settings are safely stored in the EEPROM. I'll use instead of a GPS my own NWTS device. This device connects to a Wi-Fi network and gets time by using Network Time Protocol or NTP. It then emulates a GPS signal to set the clock's time. NWTS supports both RS-232 or TTL levels, and the baud rate can be configured. In this case, this clock uses TTL and the baud rate is set to 9600 bps. The clock supplies 5 volts to the GPS device, and as soon time is acquired, GPS messages are sent immediately to set the time. As the clock boots, NWTS powers on and connects to the Wi-Fi network. Queries the NTP server for the current time. As soon as it gets a valid answer, it starts sending GPS messages to the clock and the time is set immediately. I find this clock a must-have if you like VFD tubes. Its richness of shields, the ability to change the source code and program it with new features, as well as the continued development Akafugu has made over the years, makes this a treasured piece to keep. I've already ordered the second one, so I can develop in one and have the other for display. You can also find additional material in the written review on the Tube Clock database.